In this tutorial, we are going to look at Hess Law using the question here saying, from the following data, determine the change in enthalpy of formation for diborane. We've been given the formula for diborane, which is B2H6, the gas, at a temperature of 298 Kelvin. That's a standard temperature. Okay, so here we've been given the three equations here, and we've been given the change of enthalpy for these all reactions. Okay, so now how do we apply the Hess's law for such equations? So the first thing that we need to do is to come up with the targeted equation. What's our targeted equation? We are trying to form diborane there. So how do we form diborane? Diborane is made up of two elements. We can see we have boron and hydrogen. Okay, so we're going to get our B. Okay. Yeah, so we get our B and add it to hydrogen. Hydrogen is a diatomic molecule, so it will have a 2 like that, isn't it? And then this should give us, we are looking for diborate, which is B2H6 as a gas there. Okay, now if you look at this equation, it's not balanced. We have to balance it. Okay, so we're having two boron there. We have two. Then this side we are having 1. Okay, so boron is a solid here. It's in solid state. Hydrogen is a gas. Okay, and the diborane there that we've been taught is also a gas. Okay, so we are trying to balance it. We know that here boron we're having 2, this side we're having 1, so we need to put a 2 there to balance it. Okay, then if you look at hydrogen, we're having a 6 here, here we're having a 2, so it means that we need to put a 3 here so that we have 6 hydrogen and the other side 6 hydrogen. It means that our chemical equation is balanced. This is our target equation. Okay, so now for Hess's law, when you have all these equations that you've been given, remember we need to combine all these equations for us to come up with the targeted one, which we've formed there. Okay, so let's start with the first equation. And the thing that we need to consider is that for these reactions, if we reverse them, even the change in enthalpy for the reaction, we're supposed to change the sign. If you reverse, for example, if this one is a negative, okay, it's having a negative sign. So if we reverse it, we are going to find that it will have a positive sign. Okay, and then if you multiply the reaction, you say you multiply your reaction with a 2, it means that even the change in enthalpy for the reaction, you are supposed to multiply it with 2 as well. Okay, so that's what we are going to be doing here. So let's start with the first one. The first one, you can see here we have B2H6 as a gas, as 3 oxygen as a gas, giving us B2O3. Now, if you look at our target equation, it's having B2H6 in the product. And then this equation is having B2H6 in the reactants. And if you check the remaining equation, that's the only stage you're having B2H6. That's the only equation is having that that species. Okay, so it means that for us to change this B2H6 for it to be in the products, you need to reverse this reaction. Okay, and we are saying when we reverse the reaction, we are going to change the sign of the change in the standard enthalpy for that reaction. Okay, so reverse it means that the products become the reactants and the reactants become the products. Okay, so it means if we reverse the first reaction there, we're going to have B2O3 as a solid, okay, plus 3H2O as a gas, okay. This is going to give us, so now our reactants there, you can see they become the products, okay. So we're going to have B2, okay, H6 the gas, okay. Then we are going to have plus 3O2 gas again state. Then we are saying for the change in standard enthalpy for the reaction there, which we've been given, we'll just change the symbol there. So it's negative, it will become positive since we've reversed the reaction. So it will become positive 1941 kilojoules. Okay, kilojoules per mole. Per mole. That's what we are having there. Okay, then we go to the next one. Now we have our diboron there in the products. The next thing that we need is to have the boron and hydrogen in the reactants, isn't it? If you check the second reaction, the boron is already in the reactant. It's already on the reactant side. Okay, so there is no need of changing anything. Okay, and then where are we having hydrogen? We're having hydrogen in the third one. So it means that we can maintain this second reaction the way it is without changing anything, isn't it? Okay, so let's maintain it. So we're having 2B as a solid, okay, plus, so we have 3/2, that's oxygen, gas state, giving us, we have B2O3 as a solid. Okay, so we've maintained everything. So even the change in standard enthalpy of the reaction there will be maintained. Okay, so we won't change anything there. We'll still remain with the negative 2368 kilojoules per mole. Okay, that's what we are having there. Okay, and then let's go to the third one. Okay, for this one, you can see that we are having hydrogen, right or left. Then also have hydrogen. But we notice that for boron, we had a coefficient of 2. But this one, for hydrogen here is having a coefficient of 1. And then in the target equation here, this targeted one, it's having a coefficient of 3, meaning we have to tamper with it. So for us to have a 3 where there is 1, means that we need to multiply this entire reaction with a what? With a 3. So if we multiply the reaction with a 3, even the enthalpy, the standard enthalpy change for the reaction, we are supposed to multiply it by 3 as well. Okay, so maintain the sign. We haven't reversed it. All we are doing is multiplying with a 3 so that we get the coefficient that we wanted. Okay, so let's do that. So we multiply 3 times here where there is hydrogen. So we are going to have a 3. So we have a 2 there, gas, plus, now here we have 1/2. So we have 1/2 multiplied by 3. We are going to get 3/2 there, isn't it? So this is O2 as a gas. Okay. Then it's giving us 3 water molecules there. So we're going to have 3 H2O as a gas. Okay. And then what we've done, we've multiplied our -2 for 1.8 by 3. So when we multiply there, we are going to get -725.4 kilojoules per mole. Okay. So that's what we are having. Now, all we need, after doing that, all we need is to combine the equation so that we reach our target equation. Once we reach our target equation, all we need is to summate this. Then we'll get our final change in enthalpy for the formation of our diboron there. Okay, so now let's combine the equation. Now, for you to combine them, you need to get rid of some of the species that are found on opposite side of the reaction. For example, if you have this reaction 1, you have a species that is on a product and then it's found on the reactant or the other species. Such species are going to be cancelled. Okay, so I can give an example. The first reaction there, you can see B2O3 there as a solid. It's also it's in the product here, but it's in the reactant, in the reactant here, but it's in the product for the second one. It means that such species are going to be cancelled. So this one is going to be cancelled. What else? Look at our water molecule there. Okay, so we have water gas. It's in the reactant of the first one, and then it's in the product of the third one. So such we are supposed to cancel. Okay, then we go to reaction number 2 and reaction number 3 there. So we notice that we are having 3/2 Now, these are all on the product, so you can't cancel them. What you need to do is to combine the two. So now, if we add these two, 3 over 2 plus 3 over 2, what are we going to get? So these are fractions, okay? So we have 2 as our denominator, 3 plus 3, that's 6, right? So it means that we have 3 oxygen overall, okay? So this, if we combine these two, it means that we have 3 oxygen atoms over, isn't it? We have 3 O2 gases, okay? And you can see that even here we're having 3 O2 gases. So it means that this and these are going to cancel. Okay, so now we check what else do we have? What common species are we having? Okay, nothing. Everything is done, isn't it? When everything is done, all you need is to combine the equation. Now you check what has remained on the reactants and what has remained on the product. Okay, so for the first one, we have nothing in the reactants. The second one, we're having 2B, the solid, okay, plus the third one, we're having 3H2 as a gas, okay. Then it's giving us the final products that we are going to have will only remain with the diboron there, which is B2H6 as a gas. So you can see this is the same equation as the targeted one. It means that you've you've done everything right. Okay, so all you need is to summate whatever you have here. So you get our positive 190, positive 1941 plus your negative 2368 minus, okay, your negative plus your negative 725.4 there. So it means that it's the same as having 194.1, okay, minus, because positive and minus, when you multiply, you are going to get a negative side. So you are getting minus 2368. And then again, here we are having a minus 725.4. Okay, so let's do that. So we get 194.1 minus 286.8. Okay, then minus, we get our 725.4. So there we are going to get the final answer to be, okay, so I'm getting okay, okay, so there I'm going to get negative okay, so I'm getting negative 1 that's 5, okay, so 1152.4 kilojoules per mole. Okay, that's my final answer. So that is the change in enthalpy for the reaction. Okay, so that's our change in standard enthalpy of our reaction. That's what we get there. Okay, so now this question was gotten from your topic questions. Let me just show you where these are coming from. Open the browser. Okay, let me just open the browser, and the rest of the questions have been solved. They are on the website. So I'll also show you how you can access those questions on the website. Okay, so this is let me just share. Okay, yeah. So this is the entire tutorial questions that we are having. Okay, so I just got the last part, which is question number 7 there. Okay, so how you can access the list of the questions on the website, the full video solutions. So you can open our browser. So you open the browser. So if you are using an Android phone, you can download our app on Play Store. You just search Discrete Learning Institute. Then you find the app there, you download it and you store it. Then you should be able to access our website. If you are using an iPhone and other things, you can just go on the browser there. Then you search Discrete Learning Institute. Okay, so I can search that there. Once you open, something like this will appear. Okay, so if you are enrolled in some of our courses, you will find courses that you are enrolled in. Okay, if you are not enrolled or if you haven't created an account, you'll be asked to create an account. Then after creating an account, you'll be required to pay for your course of your choice. So we are having different courses for PMed and also pharmacy courses. For example, biochemistry, we have physiology, anatomy, and we have pharmaceutical chemistry. So for example, this was pharmaceutical chemistry. So you go in the folder written pharmaceutical chemistry there, you open, you're going to find their folders written 2 semesters. So the first semester, second semester. So you pick your semester there. First semester, for example, I open, then I'm going to see these folders. So these folders are having there's one for recorded lessons. So we usually have live classes. So those classes that we have, we record them and put them on that folder on the website. So we were going to find all the live classes that we have done so far on that folder. Okay. Then we also have written materials, for example, summarized notes, assessment, lab samples, and theory sheet, any written materials. We're going to find them in the folder. For recorded videos, for the past papers, assignment, and theory sheet, you can go to this folder written past papers, theory sheet, and assessment. So you open there, you find the videos. Okay. So you find the videos for the theory sheet that you had on enthalpy, the question, the practical questions that you have. You are going to find them here, and also the same these same questions, the one written at topic 2, thermochemistry questions, full solution there. You're going to find that video. It's a 1 hour, 30 minutes video. So all the solutions were solved and they have been uploaded on the website there. Okay, so thank you so much for watching this video.